Okay, so yeah, hello everyone. Thanks for joining today. For all folks who are joining live, as well as people who watch the webinar recording afterwards. So this is the Multimodal Weekly webinar series hosted by the team at 12 Apps. For context, we are growth stage startup focusing on multimodal video understanding, and this is one of the initiatives that we've been working on over the past almost 2 years or so, meeting on a weekly basis to discuss a variety of topics. So as the name suggests, one thing that we love to discuss is research in multimodal AI and foundation models. That's why we have a lot of researchers coming in and talk about the exciting work. And other times we have, folks from our community, like developers, entrepreneurs, creatives, business people come in, talk about their corresponding application, build either around multimodal, build with apps, or, etc., like a wide ranging amount of topic. Here's the list of some of the speakers that we have over the past month or so. As you can see, mostly focused on the research side. There are talks about, like reasoning in video understanding to benchmarking of, human in the wild, continual learning of video language model, video question answering, long form video understanding, multimodal causal inference, etc. So a lot of exciting topics that we tend to surface to the community. So for today's session, we have two presentations, both are very, very exciting. So the first one is going to be from Kairui Hu, currently a research assistant at Nanyang Technological University. He's based out of Singapore. So yeah, thanks for making the time today. I'm sure it's pretty early your time. So he will give a talk on his recent work called Video-MMMU, which is the first benchmark designed to evaluate how effectively large multimodal models acquire knowledge from professional videos. And specifically, this benchmark covers 3 cognitive tracks: perception, comprehension, and adaptation, to assess the model's learning processes, which mirror human cognitive states. And then on the second half of the webinar, we'll have 2 speakers, Ku and Dongfu Jiang. Both of them are currently PhD students in University of Waterloo. And they will keep a talk on their work called GenAI Arena, which is an open evaluation platform that focuses on generative models that can include image generation, image editing, and video generation tasks. This platform leverage user feedback and votes to provide a more democratic and accurate measure of model performance. So yeah, that's the high-level details on the content of the session today. For the attendees, feel free to send your question on Zoom chat, and I will try to surface to the speakers as they present. And then after each session, we'll have a short Q&A part for each speakers. So with that, I will stop sharing my screen, and then I will let people go ahead and share your screen, start your presentation.
Okay, great. So James, can you see my screen?
Yep, we can see it.
Okay, awesome. Thank you, James. Hi everyone. It's Kairui Hu. I'm currently a research assistant at Nanyang Technological University in Singapore. Today I will be presenting an Video-MMMU, which is an interesting benchmark that evaluates knowledge acquisition from multidisciplinary professional videos. So first of all, let's start with a quick question. So imagine you are back in university and facing a quiz on neural network forward propagation, right? It is a classic MMMU style question. Would you be able to solve it on your first attempt? The truth is getting the correct answer is not easy. Some of us might be unfamiliar with the topic or the formula, and others might make mistakes during the reasoning process. As you can see, even GPT-01 can derive an incorrect answer. So in fact, real-world problems are often challenging and novel and beyond our knowledge base. So we do not always solve the practical problem on our first try, and the model may face the same issue. No matter how high quality your pre-training data is, the model's knowledge base is always static and limited. So like if we want to the model to operate in the wild, like humans, we cannot repetitively train a model during the deployment, and the model needs to like continuously acquire new knowledge to handle unfamiliar problems. So as humans, we learn from the world around us, and for models, video is their medium to interact with the world. It's how they perceive, understand the information from the world. So for model, learning from video is just like how humans learn from the world. So without repetitively training a model, we expect them to acquire knowledge from video in a way that is similar to in-context learning, where the video is just input instead of the training data. So this is what motivates us to explore how effectively the model can acquire knowledge from the video input. And to learn a new topic, we usually watch a relevant video lecture, right? I'm sure that many of us have watched Andrew's lecture about deep learning before. And in the lecture, Andrew introduced the concept, explained the formula, and strengthened our understanding with an in-video quiz. So through the video lecture, we can learn how to solve the previous question that is initially unsolvable to us. So you can see video is a natural medium for transmitting knowledge, and video-based learning is a well-developed learning paradigm for humans. So, and from the educational perspective, the learning process is not one step. It involves several progressive cognitive stages. And the first step is usually perception, which is to identify key information related to knowledge. So for example, here, we first extract the forward propagation formula, right? We need to accurately perceive the correct information. And after perception, the second step is to comprehend the underlying principle of the knowledge. So here we test the understanding with an exercise question. And the final step is about adaptation, which is to apply what you learn from the video to solve a different yet related problem. So here, the previous exam question is a perfect example. Like both use the same method and the same knowledge, but in a slightly different scenario. So if we can solve it correctly, this indicates that we indeed acquire and apply the knowledge from the video in practice. So after the video, we can acquire new knowledge and skills that we initially do not possess. So there is like a learning gain from the video, and we define the learning gain as DeltaKnowledge, which is like the performance improvements on the adaptation stage after the video. So I hope this story can help you better understand the motivation and novelty of Video-MMMU. And actually, Video-MMMU provides a fundamentally different perspective of video QA, and we can summarize them into 3 points. And the first is about video domain. Existing benchmark many have videos with natural scenes, but Video-MMU is like the first to consider video as a knowledge source or educational source. And we collect like 300 lecture style, college level educational videos, and spanning from 30 subjects in 6 academic disciplines. And the second point is about like QA design. Most existing benchmark are about general visual understanding, like visual reasoning, but Video-MMU focus on asking the knowledge acquisition process. So for each video, we annotate like 3 QA pairs in perception, comprehension, and adaptation, respectively. And last but not the least, for the evaluation, existing benchmark only focused on the final accuracy, which is like the absolute performance of the model. But a key innovation for Video-MMMU is that we evaluate not only the final accuracy, but also the delta accuracy, like how much the model improves after video. So initially, the model may not be able to solve an MMMU style question, but we give the model a video where a human could learn to solve the question by watching the video, and we test whether the model can also learn from the same. And we measure the delta accuracy to quantify the model's learning gain from the video. And we think this is actually important evaluation towards evaluating AGI, because intelligence is not only measures the ability of solving tasks, but also measures the ability to learn to solve the task, which is the learning efficiency. And we think Video-MMMU is one of the early evaluation efforts towards the goal. And we have the table here to compare the Video-MMMU with existing benchmark. As you can see, besides the 3 innovations we mentioned just now, Video-MMMU also has a longer video length and a longer question length compared to the existing benchmark. So here's a video curation process. The videos in our benchmark are curated through like 3 steps. First of all, for each college subject, we have domain experts to analyze the textbooks to identify several exam topics. And based on these exam topics, we use GPT-4o to generate some search. For example, here the query is compute activation of a neuron. So it's like a type of question in the exam. And then we use the query to search for videos on YouTube. And also for the quality assurance, we also have a 3-tier review protocol, but I'm not gonna expand this. So the result video fall into like mainly 2 categories. The first type is about like concept introduction video, where the video introduce some factual knowledge like concept and theories. And we also have problem-solving videos which demonstrate step-by-step solution to an example question in the video. So here's the QA design for each video. We annotate 3 QA pairs in the 3 tracks. And first of all, the perception question, it aims to evaluate the ability to perceive information from videos. And there are many 2 types. The first type is ASR. It's very intuitive. It's to evaluate if the model can transcribe the spoken content into text. And another type of question is OCR, which is to evaluate if the model can extract the visual details from the video, such as the formulas, charts, and handwritten notes. And moving on to the comprehension stage, the first step is about like concept comprehension. This kind of question evaluates the understanding of concept using a multiple answer, multiple choice format. So which generally like include like 4 to 10 statements. So to answer correctly, the model must be able to identify all the correct statements in the question. And the second type is problem-solving strategy comprehension. So like for videos that introduce the solution to an example question, we test understanding by presenting the same question with different input values. So in this example, the video is about like 25-degree calculation, and our question asks the same question but change the value to 30 degrees. And in this way, we can test the understanding as the cognitive difficulty like falls between perception and adaptation. It requires new calculation, while you just need to follow exactly the same reasoning process as in the video. And the last stage is about adaptation. We have case study analysis. This question tests the application of concept to some real world scenarios, like case studies. And another type of question is about problem solving strategy adaptation. So this kind of question evaluates the adaptation of the solution to some practical problems. So as you can see, the problems in the adaptation track are MMMU style questions. So although relevant to the video, they can actually be answered without the video. So this is why we can measure the the data accuracy before and after the video to evaluate the learning gain of the models. And here we also have this dataset statistics. Figure A is about like the radio distribution across disciplines. Figure B is the QA distribution across types. And figure C is about the distribution of video length. So now we can move on to the experiment part. So here it's the main experiment results, and we have some interesting findings. First of all, you can see like human experts outperform the models across all tracks. Among the models, Cloud achieved the best model score, but still show a gap to humans. And both human and model show a declining performance as the cognitive stages increase. And for the perception track, most models achieve like owning 50% to 60% accuracy. This highlights the challenge of OCR in such information-intensive videos. And for the comprehension track, as we know, comprehending such expert level videos requires the college level knowledge as the foundation. So compared to the model's accuracy on the perception track, most open source model show a 10% to 20% decline in comprehension. And for adaptation, this is the most challenging stage. Most model scores are below 50%. And this suggests that models struggle to adapt knowledge from the video to some novel problem-solving scenarios. We also analyzed the performance by disciplines. Model performs better in art and humanities, but achieve lower accuracy in science, engineering, business, and medicine. So this might suggest that models are more adept at processing factual knowledge, but underperform in domains requiring complex computation, deliberate reasoning, and like some visual analysis. And now we move on to the experiment of DeltaKnowledge. As we mentioned before, it is a measurement of the learning gain. It is defined as the normalized performance improvement on the adaptation track. And why we have the normalized metric? Because we need to account for different baseline difficulty level. For example, like improving from 90 to 95 is much more difficult than improving from 0 to 5. So for from 90 to 95, the delta will be like 50%, but for 0 to 5, based on our definition, the delta will only be 5%. So this is the result of DeltaKnowledge experiment. And again, it shows a gap between human and model. Human have a data of 33.1, while the best performing model like GPT-4o achieve only like 15.6, and some models even show a negative data. So we propose that this gap highlights the challenge of knowledge acquisition from video. The first bottleneck is like the difficulty of OCR, because such video contains very dense information. And the second bottleneck is like about reasoning, because adaptation question and knowledge adaptation is like involves some intensive reasoning process. And this may indicate that current model may lack training on this information dense videos, so it might be a little bit difficult for them to process such videos. And to have a better understanding of the data accuracy, we also introduced two metrics. The first is wrong to right rate, which is like the percentage of questions that were initially answered incorrectly, but correctly after watching the videos. And right to wrong rate, which is the percentage of question that were correctly answered before but incorrectly after watching the videos. And the result is shown here. So interestingly, model achieve a moderate right to wrong to right rates. For example, as you can see, Gemini achieves like 30% accuracy. However, their high right to wrong rates often like offset the performance gain. And in contrast, the human expert have a much higher wrong to right rate and a lower right to wrong rate. So these findings again highlights a gap between human and model capabilities in video-based learning. So now we have a quality error analysis. We annotate like 100 error case of Cloud 3.5 Sonnet, and the error distribution is shown here. And you can see the three main error type are question misreading, method selection, and method adaptation. And I will briefly introduce each error type with an example. So the first is about question misreading error. It's like a perception error about the diagram and charts or subtle visual details of the question. So for example, here the model misinterprets the diagram. It incorrectly interprets the x-intercept as 4, but it should actually be around like 3.5. But this kind of perception is very easy for human. Human can actually derive the correct answer. So our first insight is that the model should improve the perception and OCR capability to interpret the diagram and charts more accurately. The next type of error is method selection, where the model does not follow the method from the video. So for example, here the video introduced the problem-solving approach, which is Ohm's law, but the model fails to realize that it should use the Ohm's law introduced in the video. Instead, it just used the qualitative analysis, which is insufficient to solve the question. But following the video's approach is very intuitive and easy for human because we have like learned from the video and apply in exam for like we undergo this learning process for a long time. So it is likely that the model may have limited understanding of the video's approach, that the video cannot follow the same reasoning process as shown in the video. So maybe like a possible ways to have more training on the college level content. And we we also have the method adaptation error, where the model can record the correct methods but fails to apply it properly. So for example, here the video introduced DFS, but the tree here is a very small and simple tree, but the adaptation question is a more complex graph containing cycles. So as you can see before watching the video, neither human nor the model can answer the question correctly. But after watching the video, the model seemed to understand the core principle and start with the correct reasoning. But the model failed to correctly adapt the method to this more complex graph during the reasoning process. But this kind of adaptation is very easy and straightforward for human. We are naturally familiar with this learning process. We learn from lecture and we apply what we learned in quiz and exams, and there are some like gaps between what we learned and what we need to solve. But the model may not have sufficient training in this paradigm, so it might be difficult for the model to apply in a slightly different scenario. So we just suggest that maybe we can try like more training in this paradigm, where the model is an online lecture and the QA is a relevant exam problem. And we hope that this might be able to overcome this adaptation gap. We also have a wrong to right example, suggest the successful video-based learning. But I'm not going to expand this due to the time limit. So I think this is all for my today's presentation, and I hope that this benchmark provides some valuable insights for evaluating large multimodal models in videos, especially the how effectively they can acquire knowledge from video to solve a previously unsolvable question. Yes, thank you very much.
All right, awesome. Thanks a lot, Carol, for spending the past 15, 20 minutes to walk over the details of your paper. Right off the bat, I think Pranay had put some question on the Zoom chat, so you want to take a look at that? I think,
okay.
yeah, he asked a question about the experiment with 3.7 sonnet. We wouldn't go over that.
We haven't tested 3.7 sonnet yet. So as you can see from the website, like the current SOTA model, like SOTA model is not 3.5 sonnet anymore, and it will be like the Kimi new model from Kimi, and like you can also search notice that the Kimi published some new tweets on Twitter to have some insights about their new model. So I think the current SOTA is like Kimi 1.6, but yeah, definitely we will try to evaluate 3.7 sonnet in this task. And we find that why in this kind of benchmark, Cloud performed better than GPT-4o, and during the experiment, we actually found that Cloud is actually more stable. The reasoning process is more like constant, and it is more like more adapted, like handling such academic questions. But for GPT-4o, the result is kind of like unstable, and there's like conflicts in the reasoning process, and there are a lot of like method adaptation error during the reasoning process of GPT-4o. So I think that's why has the previous SOTA performance on Video-MMMU.
Yeah, great. Pranay, I think, do you have any follow-up question? Follow-up question based on that response?
Yeah, thanks. I appreciate it. I saw the, I just looked at the website and saw the Kimi preview results. I think Kimi's supposed to be more catered towards the O type of models. So that kind of is a good segue into my question about, I think with Claude 3.5, they focused a little bit more on test time or inference time thinking and processing. And I was wondering, so 4.0 will claim on their website that it's like a multimodal reasoning agent, but really they're quote reasoning agents that spend a lot of time during inference time to process are the ones that start with the letter O, just like O1. And I was wondering if you had any preliminary results on like a GPT-O model. I don't think like 3.5, and also really the internals of all these things that are not completely open source are tough to say. So like there might be like Claude 3.5 and 3.7 seem to output a bit more quickly than ChatGPT, which will explicitly say reasoning, but like it can still actually output stuff while it's reasoning in the background and not tell you that. So I do think 3.5 and 3.7 are doing some reasoning, but like to what extent, I don't know. I was just wondering if there were any, if you see any interest if like maybe the reason why Kimi performs better is this sense of spending time on inference time to process. Just whatever thoughts you have on that kind of comparison between these, not so much like more so like just feeding it into a model and like getting the response kind of pretty quickly versus like feeding into the model and then have it run loops of outputs and iterating on itself.
Okay. Thank you for this insightful comment. I'm not familiar with Kimi, and currently their model are actually not open source yet. So I cannot like go to the detail of their model response to gain some insights. But from my understanding, like their the performance might, because firstly they tell me they have some training on the lecture style videos. So I think this is the one that a lot of like pre-training data do not have. So I think you can see from the website they achieve a very high perception score and a comprehension score, and also a very high adaptation score, meaning that overall they can process such information intensive videos better than the existing models. And so this is about the data. And secondly, I think they did some reinforcement learning. And I think from my discussion with them, they share some insights that the average the average output token for VideoMMMU is the longest among all the video benchmark. It's like 2K tokens in average to answer a single question. So I think this is why they perform better. I think for answering VideoMMMU, it's like a two-stage reasoning. Like the first stage is to understand the video knowledge, and the second is to use the video knowledge to apply the method again in the MMU style question. So it's like the reasoning process is like the longer than existing visual benchmark and the image benchmark. So I think this provides some insight why they achieve the best performance on VideoMMU.
Awesome.
Okay. Yeah, cool. Thanks.
Thank you very much. Of course, we will like do some more experiment like for GPT-O series model. Yeah.
Yeah.
Perfect.
Appreciate the answer. Thanks.
Yeah. Thank you.
Yeah. So maybe one final question before we move on. I think this concept that you present called DeltaKnowledge, right? There's a concept called DeltaKnowledge that you present on the paper. Can you quickly just
yes.
can quickly explain that concept again? How do you measure that matrix?
Data knowledge is just a learning gain of the model, and it's defined as the normalized performance improvements of the model on the adaptation stage. So as you remember, the numerator will be like the delta accuracy, and the denominator will be 100% minus the initial accuracy. So it's like the performance, just a performance gain on the adaptation track, but we normalize it because we want to like account for different baseline difficulty levels. Yeah.
And the higher the knowledge, the better it is, right?
Yeah, the higher the data knowledge, then the higher learning gain the model will achieve. Yeah.
So it's kind of like if it performs well and has a low delta knowledge like Kimi versus the human, like that means it's already pretty strong without watching or learning or adapting, whatever. Like it doesn't gain much knowledge from the data. It already is pretty good. Whereas the humans here have huge delta knowledge.
Yes.
And I missed the exact formula, which I think you might have mentioned. So that would answer the
yes.
question.
Yes, I feel
But
like
is that insight kind of the case?
Yeah. Sorry, I think the network is a little bit unstable, but yeah, I feel like Kimi has a great final accuracy, but the delta is very small. So this might indicate that actually they did not improve after like learn a lot from the video, but they just have the very strong pre-trained reasoning capability. So I think it is because I'm not sure it's about their reinforcement learning paradigm or something, but I think this is why we want to like introduce Delta-Knowledge, because that is not enough to achieve a high final accuracy, but it should be more insightful if the model can achieve a high Delta-Knowledge, which means it can really learn from the videos.
Awesome.
Yes.
All right, thanks, Carol. I think
thank you.
we should move on to the second presentation. So yeah, Max and Dongfu, do you guys want to unmute and share your screen? And Carol, can you stop sharing the screen so the speakers can do it?
Okay.
Were you guys able to see the screen?
Yes, we can see it.
Yeah, so one sec. So hi everyone, I'm Max Ku, and I'm gonna present our work, the GenAI Arena, which is an open evaluation platform for generative models. So the motivation is that when we're evaluating the generative models, usually we'll compare the so the motivation is that we want to compare the pairwise comparison on two different models, and then we get a feedback that is aligned with human. But in previous auto metrics developed in the past, like PSNR, SSIM, LPIPS, and FID score, they're only limited to evaluate a certain scenario. So they have limited aspects and they're less reliable. So we kind of want to, the angle is that we kind of want to develop like an open human representative evaluation. So that's why we're trying to collect the human direct votes, which the angle is that we want to represent the real human preference. So how do we do that? Inspired by the chatbot arena, we proposed GenAI Arena, which we designed a user interface hosted on the Hugging Face space, and we allowed users to freely generate using a prompt that generates image or editing image or even generating video. And then there will be two different models generating the same set of, using the same set of input to generate the output. Then the users can vote which one is better. Let's say the model A is better, or B is better, or is tied, or both are bad. Then we want to collect those votes. And the users, after voting them, they can see which model it is. And the winning model, you get an ELO score. So we'll explain the ELO score in later slides. And since it might be difficult to do the real-time inference, we also have a surprise me button. That is, we have a large pool of pre-computed results, and then when you click the surprise me, you can just simply get the pre-computed results for instantly, and then you can get to work. So like I said, not only we support image generation, but we also support editing, which you can having a source image as input, and then we can specify like the instructions, blah, 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 and then we will have two different image editing models to generate the output. So similarly for T2V models, given a text, and then we will generate two different videos from two different models, and then the users can vote which one is better. So here are the examples of collected votes. You can see there are like different models. Some of them might perform better. Like here, a cute dog is playing a ball, so that the left one is better. And a fish eating a pelican, so both are bad in that case. And then for image editing, because some of the models, they're instruction-based, so we will rely on instruction prompts, and some of the models are source prompts and target prompt required. that is like prompt to prompt. So in that case, we want the users to input all the three prompts together to get the corresponding results to ensure the fairest comparison. And then for text to video, we will perform like 2 to 5 seconds video clips, and then we let the users to watch which one is better. So in short, compared to previous evaluation platform, we are the first work that we allows text to image generation and image editing, and also text to video generation. And more importantly, we release our human labels so that we are going through transparency, and we're hosting it a public voting process, so everyone can just participate in this process. And then after that, we use the LLM as a judge to evaluate the model to see if they're aligning with our human votings. So these are the things that our work has done and which the previous work hasn't done do that before. So here, we have included around like 16 text to image models, which is closely mostly the state-of-the-art models and some of the more recent one. And then people can play with this kind of models. So when we're running the GenAI Arena and people sample from 2 models, they can sample a list from this kind of models. And for image editing models, we also have another pool of models for users to sample. So you can see most of them are still a very latest models. And then we also added we are continually adding new models after the paper has been accepted to NERIS last year. And for video models, since this field is progressively growing, we also continuously adding new models, including the Cork Video X5B, Mochi 1, and LTX Video. So our goal is that we want to support like all kind of open source model on GenAI Arena. So to support those models inference, we built 2 libraries. One is ImagenHub, which was accepted in ICRR last year. It was a one-stop library to standardize the inference for all conditional models, and we have currently support more than 50 models. Another library is VideoGenHub, which is another one-stop library to standardize the inference for all video generation models. So GenAI Arena is heavily dependent on them, such that we can ensure that the videos we generated in the large pre-computed pool are doing in the fair comparison. And it also makes sure that when we're doing the real-time inference comparison, they're doing like a fair comparison. So now I will pass to Dongfu.
Can you hear me?
Yes,
Yes.
we can hear you.
Okay, so Max, I'm gonna need your help to turn the next slide for me. So yeah, so I'm gonna talk about the ELO rating system that we have been using during developing the GenAI Arena. So basically we have used this boundary literary model to develop how we model the ranking of the models after we collect all these votes, because the votes we have collected, they are pairwise votes. Basically, which one is better given 2 images or given 2 generated videos, and it's good research question to investigate how to map these pairwise votes into a individual ranking of each model. So basically, let's say so boundary literary model basically defines the probability of player I once a player J as a 2 pairs rating, a function of 2 pairs rating. Basically, we define the Ri as the current rating of the player I, and the Rj as the current rating of player J, and then we define the probability of player I once player J using this formula. Yeah, next slide. Yeah, so how do we update the rating of the 2 players once we have a new match coming in? So basically, we have one method that is called online iterating updating. So once there's a new match coming here, and we have the matching results, which is Sij. Sij is equals to 1 if players I wins, and equals 0.5 if it is tied. It equals to 0 if players I losses. And we have the current rating, still we have the current rating of player I as Ri, and the current rating of player Rj. So we basically update the ratings of player J using this formula, and we minus the current match results with the probability of player I wins player J, which is Pyi_j equals 1 we have defined before. So basically this becomes a function of the matching results, current match results, and the two players' current rating. After that, we can update the players' rating. However, there's a disadvantage of this method because it's pretty unstable and it's order sensitive. That means the order of the incoming matches, that basically the order of, in our case, the order of the collected pairwise votes, it can affect the final rating in a large scale. If you just shuffle the order, probably the rating will be different. Yeah, next slide. Yeah, therefore we propose to estimate the ELO ranking using a statistical estimation. Basically, this method is more stable and orders consistent. We define the maximum log likelihood estimation method and model the probability of player I wins player J using using a list of random variables Ri to Rn. Then we optimize this loss function using the MLE method, which basically you can call this function or fit this model using the Python sklearn toolkits. So that's basically how we do this in the current GenAI rating website right now. Yeah, next slide. So now we have a updated version of GenAI Arena Leaderboard, and the current leaderboard is until the March 12th and 2025. We have added some new models here, like Fox 1 Dev and Playground V 2.5. You can see for the image generation, this is the image generation leaderboard. For the image generation, we have Fox 1 Dev to be the solo image generation models, at least in our leaderboard. And we have some other models coming in like Hunyuan DIT, Pixel R, something like that. And next slide. For the image editing, we still have the Magic Brush as the solo model. So Magic Brush is a image editing method I think proposed last year, and still the SOTA in our arena. Our votes, yeah, we have collected about more than 1,000 votes in the image editing leaderboard. So the ranking is kind of it has statistical significance. Yeah. The next slide. For the text to video generation models, we have added the recent Coq Video X, Mochi, and Stable Video Diffusion, and these three has been the three SOTA view text to video generation models in our leaderboard. We know there are some recent other T2V models that we haven't added, like Wanxiang or OpenSora 2.50. 2.0. We haven't added this model yet, but we're planning to adding this model in the future. Yeah, next slide. However, there is a possibility since we are collecting the human votes from the online website. There's a possibility that the collected human votes, they might be of low quality. So to investigate what's the quality of our collected human votes on our GenAI Arena website, we just conduct a very brief, small scale human study of our collected votes, and we analyze whether the vote we have collected is a clearly reasonable vote, or it's a vague vote, or it's a wrong vote. The result is present in the paper, and here's the table. We basically found that there are some NSFW images or videos, and we just filter them out during the human study. And there are also some tech issues. We miss the images or miss the videos during the storing the videos and the images or the vote. So we also filter that out. And we just found out that more than 76% of the votes are clearly visible. So that's basically acceptable percentage. And for the rest of them, they are just either vague and only a small number of percentage, lower than 7%. They are clearly wrong vote. And so I think it's acceptable. Yeah, next slide. Yep. So after talking about GenAI Arena, we also developed another thing based on our collected votes called GenAI-Bench. So basically, GenAI-Bench is evaluating how good is MMIs as a judge. So in the GenAI Arena website, we are collecting the humans preference of the text to image generation models and humans preference to text to video generation models. However, we want to see how good is MMIs judged during to replace human in this process. So we filter some very high quality GenAI Arena votes to as the GenAI Arena GenAI-Bench data, and then we call and do the inference of the ML models using our predefined prompt template to judge whether which one is correct, just like what human does in our website. And we opt to 4 labels, either A is better than B, B is better than A, or the same good or the same bad. We define the label accuracy like this. And next slide. So we found out that current multimodal large language models, a lot of them that's pretty struggling in this preference judging in our case, in aligning with actual human preference. So even GPT-4o, it can only achieve a basically lower than 50%, near 50% accuracy in average. And other open source models, they get even worse results. It basically, this is a pretty important direction. That means if multimodal large language models can do pretty well on this task, that means it can be serving as a reward model that can be further used to improve the quality or performance of the text to image generation model or text to video generation model. So it's a pretty important direction. Yeah, next. Yeah, in summary, we have proposed a GenAI Arena as an open platform. You can still access to the GenAI Arena on the Hugging Face space in the following link. And we have discussed and have some case studies of our collected case user votes. Also, we propose a very important benchmark called the GenAI-Bench to evaluating how good MMI's evaluation ability on the multimodal generative task. Yeah, thanks for listening. That's basically what we have for the GenAI presentation.
Okay, yeah. Thanks, Max and Dongfu, for walking over the platform and the approach to getting there. Yeah, any question from the audience on the presentation?
So once you go onto the ground, index that's the end state. There isn't necessarily end product value there for end users because our product is.
We can do some live demo, I guess.
But like we can go for the Q&A section first.
Yeah, I didn't see any Q&A question yet though.
Oh, no Q&A. Yeah, so yeah, I can do the live demo. So basically our website is still on, and then you can see there are different tabs for different tasks, and then we have the generation leaderboard that shows all the models we included, and then we also have some detailed analysis such as the win rates, battle count, etc. Then in image editing and for video generation, we also have similar things like this. And for GenAI Arena, when the user can choose to prompt their prompts and click send, then it will prompt the server to inference for the 2 different models and return it as output. So currently we only support this for image generation and image editing, because for video it cannot be run on the HF space. But still we have the surprise me effort, which I really like it, because that means we can just get the output instantly. And then you can just start voting. Let's say like 3 cats and 1 dog sitting on glass. I think both is bad, but at least the left one get the 4 objects right. So, and then you can get to see which model is it. Then you can just click like a new round or like a new round or regenerate a new one. So for image editing, it's gonna be similar. So we have the source image that we can also, it can be also done through the surprise B function. And in the video one, there will be like only surprise me function is available. And then we will have 2 different models generating the video.
How do you know which is model A and which is model B?
Here shows which model is A and which model is B. So in the top left of the video.
Yeah, but what are the models here? Like which one is it?
Oh yeah, like let's say like a person is doing push-up, both are bad, then we can click the vote and then we will know the answer.
Oh, it's gonna reveal the model.
Yeah, it will show the model after the vote, so that we want to make sure that the users won't have any bias towards certain models.
So how do you choose which model to surface from the beginning?
Sorry?
Like how do you choose which model to surface in the beginning?
Oh, so it's randomly selected. So we have a pool, like we have a list of models, and then we just randomly sample 2. But of course, like we also have like some other modes, such as like a side-by-side comparison. So users can choose which one to compare. Let's say I want to compare T2V Turbo with Mochi 1. Then we get the models directly. But this one, like we also collect the votes, but all the leaderboard results we shown here is based on the arena battle. So for the side-by-side, we don't really collect the votes. And we also have playground, which people can just come and try try the models and then just play with it and see their effects. So that's pretty much how GenAI Arena has.
Yeah, I think it's really cool. And also the latency is pretty fast as well. Looks like.
Yeah, because if we are using like the surprise me function, like it's simply fetching like the stored video or the image in the backend.
Got it. And I assume you're gonna continuously adding more models as new models be released.
Yeah, we're slowly adding like new models. Like back then, when we were working on this, like we were the first who work on this, and then and back in the papers during the previous submission, I think we only have like maybe 20 models on each, like on the total 3 tasks, but now we have probably we doubled the size, and then we added a lot of like latest research, such as the ultra edit, which was like I think Magic Brush was last year NeurIPS. No, not last year NeurIPS. 2023 NeurIPS, and then ultra edit is last year NeurIPS or iClear. So we're continually adding like new models, and most importantly, like I mentioned, the GenAI Arena is mainly depends on the backend ImagenHub and VideoGenHub, which we have already open source all the code. So people who are interested, they are welcome to contribute to the library, and then we'll add to GenAI Arena. So in fact, there has been other researchers who submitted their models on ImagenHub or VideoGenHub, so that we can add them to GenAI Arena to evaluate them.
Yeah, absolutely. I think that's a great idea.
Yeah.
Awesome. Yeah, so thanks again, Max. I know we're running a bit out of time, but if there's no other question from the audience, then we can probably close the webinar. Thanks, Carol, for the first talk, and thanks, Mark and Dongfu, for the second talk.
Okay. Thank you.
Yeah, of course. And yeah, the recording of this session should be available in the next couple of days. So I'll be sure to share that with you guys. And yeah, thanks to the attendees for attending. And yeah, stay in touch for more session in the next few weeks.
Great. Thank you, James.
Bye, guys.
Bye.